So for the sake of posterity, we're doing a show and tell. We're doing a mixed class of Predict 411 and Predict 498 here. And students, this is towards the end of the quarter of summer 2015, I'm sorry. And so students are going to just show and tell on 10 minutes of any topics they want on various knowledge shares. So Angela, we're watching your screen. Is Angela Patterson will be our first presenter today.
Hi there.
So, Angela, you are officially, I'll probably stop you, I'll give you a hard stop at 10:27, because we've got to get other people. Is that okay?
Yeah, that's fine.
Okay, if you go early, if you finish early, we'll be really happy. Okay, ready, go.
Okay, so I'm going to do a short talk on market basket analysis, and I stumbled into this yesterday, and this was great. So this is about explaining market basket analysis to a non-technical audience. And where did my thingamajig go?
Uh-oh.
Okay, there we go.
I still see it.
All right.
There you go.
I didn't. Something came up in front of it and completely shocked me. All right, so here we're on the first page, and this is just a quick glance into Alteryx, which is the tool that I use to do my analysis. And I'm using their sample data, which is grocery store data. And so the analysis is based on a transaction ID, like your receipt number when you check out at the grocery store, and an item description. And it uses a priori method with building association rules. And then the section down there at the bottom is showing that they set a minimum value of lift of 1.7, and they sorted the results by the lift value. So that's kind of the housekeeping that's out of the way. And then here is an example on the left of what the raw data looked like that it was using. And I have this picture of the grocery bag bit because if I'm going to create something for management, I want to keep their attention. And on the slide, cartoon pictures tend to get people even more interested in it. But I had like a Word document write-up, and so I have these nice paragraphs in there explaining this is where it came from, and this is an algorithm, and it does this thing with that, and it groups it together and does math. And then here, the slide is a little bit wordy, but it provides a reference that a manager will need to understand the association rules. And so I've got this table format listing each of the column headers from the output, along with this brief technical description and non-technical definitions. And the best part, I think, for the manager to understand is the example section, where I've actually taken something from this data they can see, and then I'm spelling it out piece by piece to help relate it. And it's because it's important to have it on the same page or on the same slide, so that, because they can't hold it in their minds if you're explaining what LHS is, but then you don't see anything on the screen that says LHS. It's too vague. So this way I'm going, all right, LHS is left-hand side, which is the thing that came first, and in this case it's curd. So this is meaning that your customers purchased curd. And you go to your right-hand side, that's the thing that followed. So this is telling you that customers who purchase curd also purchase yogurt. And then the support score is pretty nifty, because out of all of the transactions in the entire data set, every single kind of grocery that was purchased for however length of time this covers, 2.6 of those transactions had receipts where both curd and yogurt were purchased in the same shopping trip. And then you move on to confidence, which is taking a look at, of the people who bought curd, you've got 35% of them who also bought yogurt at the same trip. And then last we get to the lift section, which is kind of showing you a measure of how dependent or independent these things are, your left-hand side and your right-hand side. And you want something that's at least 1, and if it's the more it gets above 1, then the stronger that dependence emerges. So you can see there's a definite relationship here between people who buy curd also tend to seek out yogurt to buy, because the lift score is 2.73. If the lift score were exactly 1, that would mean these items are pretty much independent. So yeah, people who buy curd also buy yogurt, but it doesn't really have that strong of a relationship. And what was neat was that in preparation for the show and tell, I was looking at these definitions so I could understand it better for describing to everyone else, and then it made a whole lot more sense to me after I did that. So we get to move on to the next slide. And Alteryx gives me some charts to go along with the table of data. So I've got a screenshot of that same table of data with our curd and yogurt, and this time I've outlined it in blue. And I'm showing on this bubble chart in blue where that left hand and right hand comes together. And you see you have this little bubble. It's kind of a smallish size. That bubble size is based on support. So you've only got 2.6% of your total shopping trips are going to get curd and yogurt. But the lift score was really high. In fact, it's sorted by lift, and it's the highest, so it's really, really dark. By comparison, you definitely have a relationship, a nice big bubble of support between other vegetables and root vegetables, and that's the bits that are outlined in red. That's the highest support score in the data set. You've got 4.3% of everyone's buying other vegetables and root vegetables in the same trip. But here, your color is a little bit less intense because your lift score here was 2.1 instead of 2.73. So what I'm getting out of looking at this chart is that management might want to consider always stocking curd next to yogurt, because this lift score indicates there's a definite dependence upon the two. So you want them next to each other so you can see them. But your root vegetables and your other vegetables probably can just be within sight of each other, but they don't necessarily have to be next to each other. And this is how the algorithm results are beginning to translate into business decisions. And then the next thing is this nifty little chart that it put out. And it's a different way of looking at the same data, and it's bringing it to life in a different way for me. So, for example, in the prior slide, the relationship between shopping bags and soda wasn't apparent at all. I didn't get that from looking at that other chart because it didn't have big bubbles. It didn't stand out. But here, because it's distance from everything else, it caught my attention. And so among these association rules that were generated by the market basket analysis, it's really clear that shopping bags and soda have a relationship with each other. It doesn't seem to be connected to other items, but we might want to consider stocking shopping bags next to soda because they have a relationship with each other. And maybe the reason they have a relationship is because soda is heavy, and it's good to have bags to help carry it out of the store. So maybe they also want to put up, say, shopping bags next to something else that's heavy, like laundry detergent. And then in the lower left section, we see our old friends curd and yogurt again, but it looks like yogurt is something of a hub. So if people buy yogurt, they also tend to buy citrus fruit and bottled water, tropical fruit, and root vegetables. So the circles that are shared by yogurt and curd are very dark because, once again, this color is based on the lift scores, and the size is based on support. So you've got kind of a mediocre size and a nice dark color. We're reminded that the higher lift indicates this more pronounced dependence between the items. So this is also telling us that if yogurt and curd are on sale at the same time, then that probably isn't going to result in anyone buying more than they normally would. They wouldn't buy more yogurt with yogurts on sale because the curd is on sale. However, if you only have one of them on sale at a time, you are more likely to sell more of the other. So if you put curd on sale, you will probably also sell more yogurt too. And then you've got yogurt and bottled water. Sorry, I had to catch my breath for a moment. So you've got a larger support. So you have a larger percentage of people buying both items in the same trip. But your lift is a lot lighter, so that they're more independent. People tend to buy yogurt and bottled water, and they don't really care necessarily where they are in the store. So it's okay to have your bottled water farther away from the yogurt because people aren't going to forget it if it isn't right next to it. And there we go. That is market basket analysis in really quick time.
Angela, that was a wonderful presentation. I just want to comment about one thing you had before anybody asks a question. Is you said you learned a lot by preparing this talk. This is the one thing I learned when I started teaching at Northwestern, is that the best way you can learn something is to try to teach it to somebody else. I think I've learned so much more by just preparing the classes. There's still so many things you guys ask me questions, and I'm like, I don't know that answer, and I get caught flat-footed, but then I have to learn it. And also, the questions and the things that the students teach me is amazing. So I just have to recommend to other people, if ever given a chance, teach something because you will learn it so well. But that was a really wonderful presentation, and also I hope students, maybe even for both of my classes, 498 and 411, see if R, I know that not all of you have access to Alteryx, but maybe look at R, or perhaps Angus might have some market basket analysis. It's a really underutilized tool. See if you can cram it in there someplace. It's great to use. Does anybody have any questions for Angela at all, or we'll move on to the next person? Okay. Angela, I want to say I really am very, very happy with this. Thank you so much. This was a great job. Okay, we have Tricia wants to go next, and Erica. Oh, Erica, are you typing a question? Let's wait. Erica might be asking you a question. Erica, I know you got a phone, so Weka has market basket analysis too. Okay, yes, it does. Thank you, Erica. Oh, she took me off of mute, I think. Turn your speakers down, Erica. Somebody put their speakers on mute. I can hear an echo. Testing 1, 2, 3. Oh, there we go. Okay, Trishul, I am going to make you the presenter now. Okay, can you hear me? Wait a minute here. Just a second here. Okay, Trishul, you want to go next? I'm going to make you the presenter. Sure. Can you hear me? I can't hear. Trishul, you may want to dial in on the phone. Are you dialed in?
Yeah. And yeah, can you guys hear me? I'm dialed in.
I can hear you, but you got an echo. You might want to turn your speakers off now.
Yeah, my speakers are.
Yeah, turn your speakers off. Let me see. Did I make you the presenter? Where are you, Trishul? There you are.
Even the 415 number?
Yeah, I see the 415. I'm getting an echo. Do you have speakers on your laptop, Trishul?
Yeah, I do. Let me try turning that off.
Turn those off, please. Testing 1, 2, 3.
Is that better?
Much better. Thank you so much. Okay, Trishul, you're the presenter. Share your screen.
Yeah, is that better?
Oh, it's much better.
Okay.
Okay, share your screen and show us what you got.
Okay, can everyone see the R screen?
I cannot yet. I made you the presenter, so I think you have to share your screen now.
Yeah, I just shared it. It looks like it had to install some Adobe software.
Okay. Are you installing it?
Yep.
Okay, perfect.
Share my screen. Okay, can everyone see my R screen? The R Studio screen?
I can see it.
Okay, perfect. Okay, great. So I'm going to do a talk on logistic regression using a very, very simple model. Basically, we're going to predict whether someone gets into graduate school based on their GRE score and their undergraduate GPA. First of all, we're going to want to install some libraries. First library here is this AOD library that's going to be used to call the Logit model. I've already installed it, so if you want just a little quick tutorial on how to install libraries, there's two options. You can go up here to Tools, Install Packages, and the package for the Logit model is AOD. And RStudio has a nice autocomplete feature, so you can see that it has the AOD right here, and you can just select that and hit Install. The other way to do it is on the lower right-hand side of the screen. There's a Packages tab, and you can click Install. And you can do the same thing again. Type AOD, and then hit the Install button. And then, so now we're going to just load the AOD package into memory with the library function. Highlight it, hit Control-Enter. Okay, it's loaded. Next, I actually create a working directory. The reason for this is whenever you have files that you want to load into R, you want to keep them in a working directory as opposed to the root directory where R is installed. Otherwise, things get jumbled up in memory. So I actually created a working directory called CR Programs Admissions Data Set, and I'm going to set it to that working directory. So now what's going to happen is R is going to be looking for any files that are going to be loaded into R from this directory. And if you want to just make sure that it actually set the working directory as this, you just use the get working directory function. And then you see right down here in the console, the working directory is just exactly what I set it to. So we're going to now load the data set, and it's in a CSV file called admissions.csv that's loaded in this directory. So it's loaded into memory, and another way to check it here is, I have it looked, yeah, it's right here in this data frame that I loaded it into called DF admissions, 400 observations of 3 variables. If you want to explore the data set, use the structure function. Come down here into the console, you see that, okay, it has 400 observations of 3 variables. The 3 variables are admit, which is our binary response variable. It's coded 0, 1, 1 if you're admitted, 0 if you're not. The GRE score that the students have obtained, and the type of the GRE variable is an integer. And same here, GPA, the GPA of the students, and then the type of that GPA variable is numeric. If we want to explore the actual data set a little bit more, like if you want to see the first few observations, you can use the head function on the data frame that it was saved into. You see the first 6 observations, so this person didn't get into graduate school, had a GRE score of 388, but had a GPA of 3.61. Vice versa, this person got admitted to graduate school, had a GRE score of 760, and a GPA of 3.00. If you want to see the last few observations, we can use the tail function, and you see the last 6 observations, 395 to 400, same logic as before. And if you want to print the entire data frame, you can use the print command, and this prints out the entire data set. Next, we're going to actually build the Logit model. So I created a variable here that will contain the formula and the outputted model. I called it logit.fit. Usually it's good programming practice to have the actual model name and then the type of model that you're going to be fitting it to. So this is a fitted model. And I call the GLM function, which stands for Generalized Linear Model. Just like in SAS, you have your response variable, which is admit, and here are the 2 predictor variables after the tilde, GRE and GPA. It's going to look for the data set that you're calling this data from, and that's DF underscore admissions. I just abbreviated it, data frame. This is just a variable name I chose. You can use any name you want. You could even just truncate this and just call it admissions if you want to. Then we have the next input variable, which is what kind of generalized linear models you want to use, and it's going to be a binomial model of type family. And so let's say you forgot the syntax for GLM. So you have 2 options. You can go over here to the help menu, and then right in here you can type GLM, and again you can use R's autocomplete feature, and then you see this is what we want. So we click on that GLM, and then we see fitted generalized linear models. So here's the syntax: GLM, the formula, which is what we have here for our linear model. Data, which is the data set that we're pulling from, the type of linear model that we want to use. In this example, we have Gaussian. There's other options you can choose. If you scroll down, you can see the types of arguments. Here we see family. If you want to actually see the family of functions that we want to use, you can click on this right here, and then you see you have a choice of binomial for your Logit, and then you guys just learned about the Poisson regression, so you can use Poisson, quasi-binomial, and then quasi-Poisson, and then also a gamma regression. So since we're going to do a logistic regression, which is also called Logit, we use binomial. Okay, so we're going to run this, fit the model. It's been fitted, and now we actually want to see what are the coefficients and the summary statistics of a model. We call the summary function, which will print out the walled z statistics, just like you see in SAS. So we see, okay, it gives us some descriptive statistics about the deviance residuals for the Logit model, the actual coefficients, the intercept, GRE, and GPA. If we look over here to the right, we see here are the walled z-values, or z-statistics, and the actual p-values associated with that. And we see that the variables GRE and GPA are significant at the 5% level of significance from the legend right here. So this little star says 0.05%. If it was a dot, it would have been 10%. If it was 2 stars, it would have been a 1% level of significance. So we know from this that the model is, or these two variables are significant. Now, how do we interpret the coefficients? Well, what this means is that for a 1 unit increase in GRE, the log odds of getting into graduate school increases by a factor of 0.0026 or 27. And it's similarly for GPA. The log odds of getting into, for a 1 unit increase in GPA, the log odds of getting into graduate school increases by a factor of 0.755. But now we don't really want just these logits, right? We actually want the odds ratio. So to get that, we apply the exponent function to the actual coefficients, which are these coefficients right here. Run that, and we see, okay, here are the odds ratios. So how do we interpret this? So for a 1 unit increase in GRE, the odds of getting into graduate school increases by a factor of 1.0027. And similarly, for a 1 unit increase in GPA, the odds of getting into graduate school increases by a factor of 2.13. And if we want to see the actual confidence, the 95% confidence interval, including the odds ratio, we can use this function CONFINT for the model with the odds ratios right here that we just saw down here in a tabular format. I'll run that. Boom. So now you see it in a tabular format. Here's the odds ratio for GRE, GPA, and for the intercept matches what we saw up here. And here is the 95% confidence interval, 2.5%, 97.5%. Now, if we want to see, okay, does this model actually fit the data better than just an intercept-only model? So what we'll do is we'll calculate the deviance statistic. How do we do that? Well, first we can just run the width function with our fitted model and get the deviance for the intercept-only model, which is null.deviance, and then subtract the deviance for the actual fitted model from that to get the D statistic. Run that, and so we see the D statistic is 19.63254. And now if you want to just double check that this was actually calculated correctly, well, we can go back to our summary function and we see here, okay, the null deviance is 499.98. The residual deviance is 480.34. Now if we subtract one from the other, we get 19.64. which is what this number is. It's rounded off here, but the out to extra decimal places, this is the more accurate number. Now that we have the deviance statistics, we need the actual degrees of freedom for this test statistic. So we call, again, same, the Logit.fit model using the width function on the degrees of freedom .null for the intercept-only model, and then df.residual, the degrees of freedom for the actual fitted model. Run that, and we get the number 2. And to double check that that makes sense, you go back up here. We see, okay, for the null model, the degrees of freedom was 399, and for the fitted model, it was 397. So when we subtract one from the other, we get 2, which matches what we have down here. Now, to actually run the p-value, to get the p-value for this test, which is also known as the likelihood ratio test, we call the width function the fitted model Logit.fit, get the chi-squared value, and then the p-value for that for the deviance statistic, which is this value right here, and then the degrees of freedom for the test right here. And since we're looking at the lower tail, we're not going to be looking at the lower tail, just set that to false. So we run that, and the p-value is 0.000005. So basically it's less than 0.01, less than 0.05. So what is the null hypothesis for this test? The null hypothesis for this test is that the fitted model is no better than the intercept-only model. We can actually reject that null hypothesis and say that actually the fitted model is better than the null hypothesis model, or the intercept-only model. So we know that this fitted model is a significant model. Now this hypothesis is slightly different from when you're using SAS. In SAS, the null hypothesis is the fitted model is statistically significant. So in SAS, you're going to want the p-value to actually be a very large number. That's a slight distinction between running this in SAS. And let's say if you want to create a receiver operating characteristic curve to actually see visually how this fitted model looks, we first go up here and call the library verification. And again,
Rachel, this is Don. Can you think you're almost getting ready to finish up? We got like a 10-minute limit, and you're kind of over.
Okay, then it's fine. We don't have to do the ROC curve. That's all I wanted to show. Yeah, that's fine.
Quick. I think people would like to know how to do that one. That's a good one. Just sort of show the curve fast, and then.
Okay, sure. So I'll just run the curve right here. Go to plots. Oh, sorry. Get the prediction. So right here, you see here's the ROC curve, and you see the hit rate on this side, and then at the bottom is the false alarm rate. This is the same thing as the true positive rate that you see in SAS, and the false positive rate, 1 minus specificity on the x-axis. If we want to see what the actual area under the curve measure is for this Roc curve, just run this code right here, and we see the value is 0.63. So it's not that accurate. It's a little bit better than just the random value of 50%. And that's it.
Well, thank you very much, Trishul. I again want to encourage students, if you're not super familiar with R, it's the future. I mean, it's one of the, SAS is certainly critically important. You got to know that. But R and Python are languages you really are going to have to know for your career. So if you can force yourself to do something with your project in 498 or 411 and force yourself to do something, do it. It's a good learning experience. And this is a good how-to. Trishul, do you think you could send me the slides and I can post it for the students?
Sure. I didn't create a presentation, but I can send you the script and the actual data set in the CSV.
That's what I meant. I meant the data and the script. That would be perfect.
Sure, no problem.
Thank you so very much. Okay. Who else? Do we have another person? I didn't mean to give you the bum's rush, Trishul. I'm just trying to keep it moving along.
No problem. It's quite involved script, so I understand.
Okay. Josh Meek looks like he's my next guy, and again, thank you very much. This was a really nice for you to have done this for us. Josh Meek, I am going to officially make you the presenter now. Okay.
All right.
Josh Meek, now presenter. There you go, Josh.
Okay.
What's your talk on? What's your talk on?
Yeah, so I'm going to talk about Beaker Notebook.
Oh.
Okay, there we go. You guys see my screen okay?
Yep.
All right.
I don't even know what this is.
Yeah, well, it was pretty new to me as well, and I try to stay on top of things. So a couple of weeks ago, I guess almost a month ago, I went down to SciPy in Austin, and it's kind of funny. You see this a lot between specifically the Python in our community. There's a bit of competitiveness and sometimes almost antagonism. I don't know that it's totally necessary, but with the cool thing about the presentation, about the Beaker Notebook presentation is it's totally against that. It's all about integrating multiple different languages to basically do your work well. And so, Beaker Notebook. Before I jump into that, so I'm sure a lot of the people in the class, in both of the classes, they probably use multiple different IDEs, different development environments. You have RStudio, maybe you're using SAS. There are IPython notebooks, or maybe you use something like a text editor like Sublime Text to run your scripts and things like that. And so you're constantly having to bounce between different languages to do different things. And if you're like me and you have a MacBook, you don't have a lot of real estate, you're jumping around a lot, and it's easy to kind of get lost in all the various windows that you have. And so that's where Beaker Notebook comes in. It's a notebook-style development environment with a polyglot architecture for switching between languages. So what that really means in short is that you have a notebook, kind of like an IPython notebook-like development environment, and you have the option to switch between, I think they support 13 or 14 different languages now. I guess it's 14 based on the slide, and they're adding new ones each day. And so, as you can see there, that's kind of the full suite. I mean, I know a handful among those, but if you're really into the visualization side of things, you might use JavaScript or Groovy. If you're more into, I don't know, maybe you like scikit-learn, you'll use Python. So there are lots of really cool options there to kind of test out new methods, and the best part about it is you can do it all in the same environment. So what this kind of looks like is you have cells in a notebook, and you set the cell to the programming language that you want to use. And so if you look on the bottom left, that's a Python script, so importing the pandas module or pandas library and reading an JSON file. And then you push the output to R, where you can use some of R's base plotting functions to create a graph. I guess to create the setup for a graph, and then you can shoot that into JavaScript to produce your visualization. So I thought that was really nifty. It's kind of like I mentioned before, it's kind of a new application. They're building it out, but I think there's a lot of promise in it. And so I'll jump over here to just a couple of examples and make this really quick. This is the Beaker Notebook homepage, and there are a number of different examples. Some of them have lots of different languages integrated. Others, this one uses Python 2 and 3 in the same notebook. So the one that I'm going to show is here, the auto translation one. Just really quickly, so you can see here that, and this is just meant to illustrate how you're able to auto-translate between languages. So he starts with Python, creates a variable for a string, sends that into, creates the object, and then prints that object in JavaScript, where you can do it as well. If you want to do it in R, it's a slightly different syntax, but it shouldn't be too unfamiliar for people who use like the dplyr package or some of the other apply packages in R. Send that over to Groovy, to JavaScript, and it goes on and on. So I think you get the point there. But it's for me, this is a huge advantage to have an environment like this, because I like scikit-learn for certain types of machine learning, and I like R for other types of statistical modeling, and each one has different advantages. When I took machine learning last term, SVMs just took forever to fit in R, and so I didn't have that much memory on my computer, and so I couldn't run the different types of models that I would have liked to really sort of determine what was the best fit for what I was trying to produce. So scikit-learn has a really great function for that. So to have the option to kind of bounce back and forth between modeling options is really cool. So that's it in a nutshell. I guess to keep it really short, there are a handful of resources here at the web page that I just showed you, the examples, and then also if you click over here to the videos, there are I think 2 different videos. So this is the SciPy video, the video I saw at SciPy this year. They also have one from PyData, and then also Spark R, which is really really popular right now, gaining a lot of interest for folks in the big data community. So in a nutshell, that is Beaker Notebook.
That is, this is Don. That's amazing stuff. This is, let me just give you my personal opinion on this stuff, is that this is a very fascinating tool. I've never seen it or heard about it until just 30 seconds ago, but I think this is remarkable. I would recommend that students look at a tool like this. I'd be willing to bet more of this type of tool is going to follow in the future. You're just saying basically look at the website and the examples and the videos, and how quickly would a person like me who's never even heard of it be able to get up to speed and become functional in this?
I think it's really easy. I mean, if you go to the Beaker web page, they have a quick start guide there. You download it to your local machine, and you can have notebooks up and running in almost no time. So, like
is it free or is it?
It's free, yeah. It's completely open source, and the really cool thing about open source in general, but specifically the guys developing Beaker, is they're really, really receptive to feedback right now, and they're trying to build this out to meet the needs of different types of data scientists and data analysts, because they want this to be a tool that people use. And like I said, you see so many things on data science messaging boards and things like that, where they're sort of pitting R and Python against each other, or different visualization libraries, and it's kind of ridiculous. So their perspective is that by putting everything in a single environment, you can really exercise the full range of creativity and use all the various things. So the hard thing is, of course, learning all the languages, but you can pick and choose the things that you like and that you want to become proficient at, and have it all.
This is really quite nice. Can we, if you send me the slides, I would love to post these for my classes and going into the future, if you'd be willing to do that.
Yeah, absolutely.
Perfect. Do we have anybody else? I know we're running late tonight, a lot later than we expected, but does anybody else want to talk tonight? Or
Don, did you want me to spend a couple minutes talking about orange data mining?
Oh, sure. Yes, I did. This is Thomas Egan.
Yeah. Sorry.
Oh, yeah. I definitely want you to do that. Can you do that for a few minutes?
It'll be quick.
Perfect. This is yet another powerful tool. This is open source, right?
Yes, it is.
Okay. So Josh, I'm making you a participant again. And then after you go, I'll try to do something very quickly about Ensemble Models, and then we'll call it a night. Okay, Thomas, you're on.
Hopefully I'm on. I don't know. I'll have to see if it lets me share my screen. But while I'm seeing if this installs here, I started using orange data mining to build decision trees for some of our 411 work. The computer's doing something here. Looks like it's trying to let me share.
It might take a second or two. There you go.
Oh, okay, good. Can you see this web page I have up here?
It's just loading. It'll be there in a minute. I can see your mouse moving. There it is. And this
Okay,
is free.
cool.
This is free?
It's free. It's Python based. It reminds me of Angus in the sense that it's got this graphical user interface where you can kind of drag and drop elements and connect them to do data analysis and build models and so on. I'll pull it up here and kind of get a sense of what it looks like. You can kind of take these different elements and just drag and drop them onto the screen to start building models. You know, I had started using Angus and kind of hit a little bit of a wall in terms of what I wanted to get out of it. And a couple months back, I had been at a workshop at work where one of the researchers had done a quick demo on Orange, and I figured, let me try to give this a shot to see if I could get something out of it. The learning curve to get up and running with Orange was steeper than it was with Angus. With Angus, I had it installed, and I was playing immediately. With Orange, it really took some getting used to. You know, it is free, and there is not great help out there that I could really find. So that is a limitation. But I was able to figure it out, at least to start building some basic trees. But as you can see here, I pointed to a file. Here's the wine file, CSV file that we've been working on in 411 for Unit 3. I wanted to build a model to predict missing, to impute missing values for the number of stars. And the first thing I've got to do is I've got to come in here and I've got to tell Orange what my class variable is and which attributes I want to include in my decision tree. So as you can see, I removed target and index. I made stars my class variable. This is where it gets a little tricky. Because you're building a decision tree, it wants you to discretize variables here. And I went through and you can kind of play with this quite a bit. For your, for the class variable, I wanted to put in custom intervals here to make sure that it was predicting 1, 2, 3, and 4 stars exactly. And then I kind of, you can play with it, have equal frequency or equal width discretization for all these different variables, or you can override it and have a custom breakpoint for each one. And then it wants this preprocessor, which I still don't completely get. And for full disclosure, I should have said this right up front. I am not by any stretch of the imagination any kind of an expert on the use of this tool. And I'd be very interested to hear from anybody in any of the MSPA classes who've used it. I can't be the only one who's used it. So I have to think that somebody out there has used it and knows it better than me. So don't think that I'm some kind of an expert here.
No, Tom, don't apologize. This is you discovered a tool for this class, and you're showing it for us. And the purpose of this is not to make us experts. It's to show us that this is out here and give us enough information that the students who are interested will dive in and attack it.
Yep,
so this
great.
is perfect.
So in addition to discretizing continuous variables, Orange wants this preprocessor. So I'm telling it here to impute missing values. It uses a Bayesian model to impute missing values. You could also tell it to use the average or random values. And then when I built the classification tree, and you can see it gets awfully messy when you start putting a lot of elements on the page. But for the classification tree, you can select attributes using information gain, gain ratio, Gini index. and then you can kind of play with it and tell it, you know, how deep to build the trees, when it should stop splitting, and so on. And so just kind of playing with it, you can see here I built a tree. And one of the things I liked about what Orange does is that for each leaf of the tree, each node in the tree, it gives you these pie charts that gives you some sense of the split and how good the split is. And you can kind of see here that this isn't a great tree. One of the things I like as well is that in each leaf, it's going to show you here the target class probability, which I really like. And if you notice up here, you'll see that this one is shaded a little bit. It predicts the target class at 69%. So this is the most successful leaf here. But then it's also going to show you the number of instances. In this case, is 294, which is really not that high. But I kind of just like the way this laid out and the ease of being able to kind of get a quick look at how successful it is. One of the things that I thought was easier about using this than using Angus is this test learners widget here, which shows my area under Roc and my classification accuracy. And again, you can see here it's really not that great. Area under Roc is about 64%, which is not that great. But it retests every time. So if I went in here and I said, you know, don't split below 6, and if I apply it again, you can see here it regenerates this. You can see that little test learners ran around again. And if I look here, it actually doesn't get that much worse by building a simpler tree. I can go back in here and look at how it splits the tree. It's a little different here. And then lastly, the other thing I would show is in this classification tree viewer, this gives you the logical details for each leaf on the tree. So as you can kind of imagine here, cutting and pasting this into a SAS data step is not too onerous with a little bit of manipulation. So I kind of like the ability to cut and paste that out of here and be able to use it in a SAS data step for imputing missing values. That's really about all I've done. I did find some other limitations with it as well. You know, you can see you've got, you know, some other visualization tools here as this attribute statistics widget. You can drag that on there and it'll build you some histograms and box plots and stuff like that. I couldn't find anything to show me accounts of missing variables, excuse me, of missing observations. And found that a little troubling. I wasn't able to figure out, I didn't spend a ton of time on it, but I wasn't really able to figure out how to do that. There were some other little things that weren't so convenient about using it. I did have a really difficult time getting it installed on my PC at work. I think there might have been an older version of Python it's still buried somewhere in the image, and it gave me all kinds of trouble getting it installed at work on my home PC. I installed it fine. And like I said, compared to Angus was super fast getting up and running. This was a little steeper learning curve, but I think if you are willing to spend the time on it, I think there's some really useful stuff in here.
Hey, Thomas, can I ask you a question? This is all Python-based, obviously, right?
Yep.
Do I have to be a Python expert to use this, or is it literally a drag and drop?
It's literally drag and drop.
Wow, and it's of course free because it's Python, right?
Yep, the whole thing's free.
So again, for students, is this competing with Panda, or is this something that works alongside or with, or how does that work with Pandas?
I really don't know, to be honest with you.
Okay.
I'm a complete novice when it comes to Python.
Okay, well, that's even better because you can hear that Thomas is a Python novice, and he's now using the power of the tool. Again, I would recommend students to look into tools. This seems to be quite an interesting tool, and it's free. this might be worth. Don't leave this program, the MSPA program here, without exploring stuff like this, because there's not a lot of people out there in the real world that know about all these tools out there. And if you have access and knowledge of stuff like this, you can become extremely valuable to a company very quickly. So try to poke around with some of the stuff you're learning here tonight. It's very good. Ken Mayer says Orange Biolab. Thomas, could you post all the stuff you have or send it to me, and I'll post it with the stuff that anything you can send me, I'll post it with the recording.
Yeah, it's really just this link. All I did was just show some of the stuff that I had built. So I don't really have any slides or anything like that to share. But yeah, this is the URL right here.
Okay, well, send me the link then. Okay, what I'm going to do real quick is unless anybody else really is dying to do a talk, I've had you guys on the phone for 2 hours tonight, and I don't want to keep you too much longer. So I'll show you. Somebody had asked me about Ensemble Models. I'll show you that really, really quickly, and then we'll call it a night. How about that? Let's see. Did somebody feel like they've been cheated out of presenting? Because maybe we'll have another talk later on if you want. Nobody seems to be too concerned. Okay, I'm going to do a real quick talk on Ensemble Models just because somebody had asked about it. So we'll, let's see. Thomas, you guys can all see my screen, correct?
Yes.
Okay, great. Let me see, tree types. Okay, I'm just going to show you the general idea of an ensemble model. Now, remember when I sent out the announcement, somebody asked me about ensemble models, and what I did was I sent you a couple of links of the wisdom of the crowd. Did anybody get a chance to watch some of those videos? Okay, perfect. Thomas did. A couple of you guys did. The whole purpose of this is the wisdom of the crowd. The whole mindset is this, where they get it all started back about 100 years ago. There was a county fair in Great Britain, and they said to people, if you guess how much this cow weighs, we'll let you keep the cow. And people guessed, and it turned out that people who guessed, nobody got even close. However, the guy, I think it was Thomas Gallen or Galson, or I forget the guy's name, when he found out that when he averaged everybody's guess of the cow together, and he averaged it all out, it was within 1 pound of how much the cow weighed. And so I sent you a couple of links where people recreate the same experiment. They're walking around with a jar of jelly beans, and they say, how many jelly beans in the jar? And so basically when they do this, people guess, one guy's guessing 3,000, and one guy's 50,000, and one guy's 200. And when they average them up, I think one guy in one of the videos that I sent came within like 5 jelly beans out of, had 1,400 in the jar and came up within 5, and one guy had like 4,500 and was within 30 or something. These things can get extremely accurate. So it's a fascinating thing. Just poke around wisdom of the crowds. Now, I don't want to say it's foolproof, because if you poke around on the internet long enough, you'll find times when it doesn't work so well. But it's a very powerful technique. And that mindset is the same thing that goes on with ensemble models. What I'm going to do here is this is a demonstration that I do for some of my customers where I'm using all sorts of different types of decision trees. And I'm going to delete some of these guys just to make it faster right now. And right now I have a situation where I'm going to have like a regular C5 tree, a shade tree, a cart tree, this is a cross validation, this is one with entropy, this is some gradient boosting. See, these are some different types of trees. So I'm going to run these guys real fast and build some models. And then I'm going to show you what the idea of wisdom of the crowd is while these run. So this is Enterprise Minor, but you can do this with anything. And in fact, if you go back with what I was showing you earlier tonight with the Poisson models, I did an ensemble for you. So let me open this up while my Enterprise Minor is running. In fact, it has run. Okay, so there you go. So the whole point here is it's just going to be a simple case of taking an average. So let me just show you all of these guys. So these are all of my decision trees that I have. And this is on a test data set. So you can, incidentally, this is another point. I'm going to do a talk on trees going forward at another time. But you can see that that people will tell you things like, well, the cart is better than the shade and the gradient boosting. They're all about the same. Trees are trees are trees. They're remarkably resilient little animals. They really all, and it doesn't really matter. You can't break a tree with a sledgehammer. They're really powerful. But that's not our point right now. I want you to just see that these are all these trees. Now, what you will notice is that if I were to, SAS incidentally has a node that does an ensemble. Now, there's lots of ways I can ensemble, but probably the most common thing to do is to just average things. So if in SAS, I can just throw all my models together, and SAS will average them. So if this guy predicts 5% and this predicts, 10%, and this predicts, 11% and 6% or whatever, you average all these things together, you might get 8%. So this guy here is going to average, and it's just like the wisdom of the crowd, where you're equally likely to guess too high or too low. So let's run these guys together and see how the individual models rate against an average model, where I'm averaging them all together. So this is the individual guesses for how many jelly beans are in the jar, and this is me averaging them all out. So I would highly recommend, they're kind of entertaining videos that I posted for the announcement. I recommend watching one or two of them. Again, I really don't want to give you the impression that this is a panacea and it's always foolproof, but it can be a remarkably powerful tool. So I want you to know about that. And they really do tend to work. The only cost about this is that they're difficult to interpret. Once you start averaging models together, it's hard to interpret it, whereas when you have a regression, you can just look at the coefficients. So let's see how this guy performed. So averaging a bunch of trees together, let's see how the model performed. So this green line here is my ensemble. And you can see my ensemble has a lift over everybody else. So he's better. You can just see there's a difference in the Roc curve here. Now, you say, well, that doesn't seem to be that much. But when the insurance industry found an even smaller lift when they started adding credit scores to people's driving, that made them billions of dollars. A lift like this in the right industry could make a lot of money. And if I give this thing different data or a different data set, sometimes these ensembles can really do a great job. So, I'm just trying to show you here that this ensemble was the best model, better than everybody else. And if I look at the area under the curve, the Roc curve, 78% versus 77. So it's like a 1% improvement. And yeah, this case, it may not have been a major deal, but the point is that these ensembles, especially for very difficult models, can tend to be highly powerful. And let's just go back real quick to the data set that I did before, where one of the last things I did was I built an ensemble, where I simply built several different models, and I said, my prediction for my regression and my negative binomial and my hurdle models and my Zen models, add them all up, divide by 5, and that's my ensemble. That's it. It's nothing. And you know what? I don't have to do this with just that. I can do something like this. Maybe I'll do 2 times my regression and then maybe divide it by 6. So I get to weight the regression twice if I want. I don't have to do this. I could take a median or a mid-range. I can do anything I want with this. There's nothing special about an ensemble other than you're just combining a bunch of predictions together and you're averaging them out. They don't all have to be trees. I could have just as easily thrown a tree and some neural networks and some regressions and ensemble, those things. So it's a nice way of combining lots of different techniques together. They don't all have to be the same. This isn't, I'm trying to think of things you have to merge together. Okay, forget it. I don't have a good analogy, but I'm sure I'll think of one later. But this is basically ensemble models. You build a bunch of little models, and you average them together. Incidentally, that's what a random forest does. My understanding is that the ensemble, Thomas, what was the Joshua Meeks question? Oh, I lost Thomas.
Sorry, it wasn't really a question. I read recently I think it was an article on Kaggle about ensembling, and they were saying that if you have models that model the data differently or different aspects of it, that your ensembling tends to improve, because if you have highly correlated models, then you're essentially getting the same sort of performance and looking at the data in the same way, if that makes sense.
Yeah, the short answer is there's a lot of theory behind ensembles. My personal, and some of it may be, will be different from what I say. My personal opinion is it's simply the wisdom of the crowds is why it tends to work. I want to say that I usually find that ensemble models do perform, they don't always perform the best, but they usually perform as one of the top performers, and they also tend to be reliable. Whereas, like, let's say we're going to use a decision tree, and I change my data around a little bit. If I look, here's what I like about the ensemble is it's very stable. So if I were to change my data, right now this cross-validation model was my worst guy, but if I mix the data up a little bit, he might be the best. And then this guy over here, like my cart model, was pretty good. He might fall down a little bit if I change and mix the data up. These guys are not stable in that they'll move up and down, whereas this ensemble will almost always consistently give me the same accuracy over and over. So I like the stability of it. I like the fact that it usually over time does give a better accuracy than using just one model. The cost is that it does tend to be complex and is hard to interpret like a neural network, but that's the cost. And yeah, you're right. If you have a bunch of bad models, and in fact, there's a lot of modeling tools and techniques that are sort of got an ensemble underneath it, like random forest. A random forest is a bunch of quasi-randomly generated trees where you basically are taking random subsets of the data and random subsets of the variable, and you build a tree. And the tree's probably like okay, but it's not super good. But you build like 500 of these trees and average them together. That's just a ensemble model on steroids. So the idea behind ensembles is used a lot, and you just may not even be aware of it. So that's everything I have to say on ensembles. I don't want to keep you guys on the phone too much longer since it's 11:20. But do we have any final questions tonight? Or oh, great, Josh. If you could send that to me, I'll post it. So Josh has, oh, here we go, something about Kaggle and the Ensemble guide. I'm going to copy and paste this thing, and tomorrow when I post all this stuff, I will definitely send it to people. I mean, I'll post it. Whoops. Guess what, Josh? You may have to email that to me.
No problem.
Okay. Hey, does anybody else have any questions tonight, or we'll call it a night? Well, I'm hearing stunned silence. Either you guys are all just taking this all in. There you go. James gives a resounding thank you here. There, that's what I'm looking for, guys. Thank you to all the presenters tonight. I know it's kind of scary to do these presentations, but it's a lot of fun, and the students tend to really appreciate getting exposed to all this different knowledge. So I really appreciate all you did. So I'm going to stop recording now.